This video will finish up project 1 for a while. I'm going to have to spend weeks taking data, and I'll come back with either a web page or whatever to discuss the results. But this is my final printed circuit board, and on my web page at qsl.net/AA7FO/aces.html, where I'll have a link to this video and then some files related to it, pointer to the schematic, a image of the board layout, and then a PDF that will allow you to print it yourself if you're interested, and you can build the same thing. Now I use these 2.54 millimeter headers for a lot of stuff. If you'll remember, this is where the signal comes in. There's a branch here that outputs a calibrate signal, and then we go through here, through the device under test, and output the RF signal through the transistor, and then we input the frequency, start with a pure sine wave at a low frequency, slowly crank it up until the amplitude of the RF out here is equal to the amplitude out here. Now, if your signal generator is constant throughout the entire band that you sweep, you're okay. If the amplitude decreases as you go up in frequency, then you're going to have to check this output against this one. So I put a little switch in here. I call it a switch. It's not that. It's a 3-pin header. If I put this is a Berg connector. If I put it here, then the output that would come here comes out here. And here I've got my scope set up so that I can measure the amplitude, and I'm doing this where this signal out here is 50 millivolts. If I crank in, how do you like my English? If I input an RF signal that's too large, the output from the amplifier becomes distorted, and I just use the minimum RF signal here that you can measure. And I have the output here going to a Rigol DS1054Z scope, not one that you typically find in low-end labs. You can use a RF meter that can go up to 30 megahertz or higher, or build you an RF probe with an amplifier and a meter. I have one that I made myself a long time ago. One time I used to build what were called Muppet boards, and this was when I had the call K7QO, and I did this in January of 2014, 11 years ago. Consists of the RFN coming through here, diode detector doubler, then an op amp with null adjustment here, and the output feed here, and then I determine the sensitivity here. This is only good to about 50 millivolts, so scope is better. You've got options. You remember one time in a previous video, probably the last one or so, well, maybe when I just started this thing, I mentioned that I thought, well, I knew it had to be, but I said, I bet you this was 50 ohms. Watch this. This is what I call the Chinese critter checker. I believe some ham came up with the circuit, but you can find these on Amazon and eBay and AliExpress for under $15. It measures resistance, inductance, capacitance, transistors, diodes, all kinds of stuff, critters. So watch this. I'm going to measure the impedance at the input here. .0 ohms, but the leads here take up about a half an ohm, so that's within 1%. All these blue resistors here are 1%, but this is a little 27 ohm resistor here is a 5%er, and this is a 5%er. So there's where my 1% error is. That's good enough for government work. So you see, this is just a nightmare. This is my power supply, and what I can do here is I can feed it to 5 volts, which Mr. Wenzel recommends or built the circuit for, and I can run through my test and get a value for F sub t. And I did that. Now remember, using the same checker, I had I had a 2N3904. And I got them dated here. This was September 16th. Now said I was going to do the F sub t test, and I measured H sub Fe on the critter checker at 286. Well, using 5 volts, I ran through the test here very carefully, and I find that F sub t is 172 megahertz. And that's a fairly respectable value. Then if you go to the data sheet says, hey, you need F sub t to be a minimum of 300 megahertz. So you're going to jump up and scream and holler and say, oh, you got a fake transistor. That is not true at all, because go look at the data sheet. They measured the 2N3904 with a voltage C sub E. The voltage between the collector and the emitter was 20 volts, and the emitter current was 10 milliamps. If I put 20 volts across here, I don't know what I'm going to get for the current, but it's not going to be 10 milliamps. So I'll have to run some more tests. I'm going to run this F sub t at 8 volts, because a lot of circuits are going to have 3904s running at 8 volts because of an 8 volt regulator. Run it at 9 volts and then at 12 volts. I have nothing, and I don't remember anything that had 20 volts anywhere. I took a second 3904. This one's from AliExpress. This one got an H sub Fe of 430, which is the same batch, but it got a high value. I measured its F sub t and got 188 megahertz. This was September 18th. So what we've got here is I've got a device to check transistors, and if I obviously get a fake, they're going to, this F sub t is not even going to be close to that. So that's it. I hope I went through a lot of trouble on this one little project, and the reason for that was to go through all the nitty-gritty on how to make printed circuit boards, what have you. So now we're going to take off like a bat out of hell, and we're going to do a bunch of stuff. Some of it you're interested in, some of it you're not. You get to pick and choose. I'm just going to try to open a restaurant and give you a whole bunch of items on the menu. Thank you for your time. Thank you for your interest. I hope you enjoyed the series so far. I'll try to improve my speech, try to come up with some interesting experiments, projects, and things to do in your lab. Again, appreciate the likes. Like everybody else on YouTube, we're just nothing but critters on the corner. I'm not getting paid anything. I'm not advertising anything. Oh, I am advertising something. My friend Jeff at Amazon.com has this critter, and I saw it the other day, and this is it. It's a, let me turn the light off here. Okay. And what it is, it's a film viewer, slide viewer. What it is, it's backlit, and you can change the intensity. And this is going to come in handy for checking printed circuit boards. Let me take this one, look at this one. This is a circuit board which just has the VXO on it. If I look at the top of the board, you can see the outlines, you can also see which holes I've drilled, and which ones I have not. So this can be used before you put any components on the board. You can check it to make sure that you've got all the holes drilled, because you do not want to come back and drill after you got components on it. Now, this has got a critter on it, and I don't have a blank board. I'll do one on the following videos, but if you flip it over, you can see before you even drill, right after you etch the board, I'll do one, you can take your little magnifier and scan the board for errors. You know, look at the quality of the board, make sure that you're not going to have a defective board that you're going to put $20 worth of parts on or whatever and not have work. So this thing costs $17.99 from Jeff, and I will give you a link on the webpage to it, or you can just go look. I had to go through a couple of searches to find the right keywords to find it. It's 30 centimeters by 22 centimeters, and it's perfect. You know, I said hold the board up to the light and look at it, but those days are gone. And like I say, it's got low intensity, medium, and high. Hope that didn't blind you. I hope the camera was able to handle that. It's USB powered, and there's no battery. You just have to use a wall wart that gives you your 5 volts. Okay, thank you. I'm out of here.